Welcome to the Info Cloud. In this class, we'll discuss about the basics of statistical test and the analysis with the help of GraphPad Prism. So we'll see how we can perform basics analysis in the GraphPad Prism. So today we'll see the basic things like the graph constructions, box plot, bar plot, t-test, when we should apply t-test, when should we apply ANOVA, and when we should apply post-hoc analysis like Tukey's and DMRT. So we will see how on which kind of data we are having based on our objective, what kind of test we should apply on that. So before starting the statistical analysis or the applying any test, we should understand that our data should follow a normal distribution. Means our data should be normal. Normal just means it shouldn't have any outlier. Or if outlier is there, you can remove or you can delete it manually, or databases are there or these software tools are there by which you can remove the outlier. Then we'll start the analysis. So today we'll see the GraphPad Prism. So you can download the GraphPad Prism, okay, by simply type on Google, and this is a paid software. It's a bit costly, so you can try the trial version of this. So you can start from here. This is the you can trial version. When you press this, the downloading will get a start, okay, and then you can install it. It require a key which you will get in the email, so you can install the trial version. Okay, so I have already GraphPad Prism, so I'm not the downloading it. So I have this GraphPad Prism 5. So this is the user interface. Wait a minute. Yeah. So this is our GraphPad Prism. Okay. So first we'll see how what kind of data we are having. So I'll show you the data. This is our data. I think it is visible. Yeah. This is our data. So we have a data in the form of treatment. So I have different 22 treatments are here, and the values for them we can say the x, y, z. This is just nothing a variable, or you can put any kind of trait here. Okay, so I've just put w, x, y, z. So we have a 4 different trait here, and the treatments is here. Okay, so we have observed or we have recorded the values for these traits under these treatments. So this data we are having, so this data have 4 variable and the 22 treatments are there. So what kind of test we can apply in this kind of treatments? So first if we are interested in the box plot, bar plot, which kind of data, which kind of trait or the variables is showing the increase or decrease kind of things, or the diversity we can analyze. So just we'll start from the basics. So I've copied this here, and okay, now this is the GraphPad Prism. Okay, so in this GraphPad Prism, so GraphPad Prism basically is a standard software which is accepted in the all over the research world. People also write in the research paper that we have analyzed our data by using the GraphPad Prism. So GraphPad is a professional and standard software. Okay, so there's many options like XY column. So based on our data, what kind of data we are having, we have to choose the table type. So this is just nothing but a table type like XY column or grouped or the contingency. So likewise we can select. So in our case, we have organized or categorized our data based on the columns here. So we'll take column statics. Okay, we'll choose this one. Then there are some options what kind of graph you are going to make. So you can use the options. So suppose I am interested in this box plot, so I've selected this. So for box plot there are some options like we can select this likewise, then we can create. Okay, once you press the create, you will get a table like this. You can paste your data here. Okay, this is just like a simple Excel only. You don't need to confuse. You can paste your data as just as you paste in the Excel. Okay. Then how you perform analysis? When you paste your data here, it will appear in the data table. So in the left column you will see, left side you will see data table, results, if you perform any analysis, then the graph. So when we press here in the graph section, we'll get this kind of graph, okay, because we have already selected the box plot. So we'll get this kind of graph, so we can customize it, okay, or we can beautify it to represent it well. So how we can do that? We just delete these things. We can write the y-axis title. Suppose this is just range. So I'm just for this is just our, so I can write anything, range. Then x title, this is the variable r here. Okay, we can delete this. This is just the extra thing, so I am deleting it. Okay, what you can do, this is just a demo, okay, I'm just seeing how we can construct the graph. So I'm just beautifying it. So I'll just make a square of the rectangle. We can choose the color scheme, okay, like we can choose like this, and we are having a many options. We can choose whatever we want. So this is very simple, so I'll choose like this, okay, this one. So suppose I like this one, so I'll choose them. I can also fill the blank reason by the background color of the plotting area. Suppose I'm choosing this, okay, now you saw this, okay. You can also customize this. Now we have just constructed our box plot from these data. How we can interpret? So we can see the most of the observations for this W are falling under this, or likewise we can see the difference. So this is just an open eye observation. We can also apply the test to just differentiate, okay. Now I just want to tell you, based on the data type or the data recordings or observation, we have to decide what kind of test we should apply to get maximum inference or the maximum output that it could represent well in the paper or as a inference. So this is just a beautiful slide, okay. So for this this is just slide to show what kind of data we are having, or sorry, what kind of test we should apply on the data type. So if you have a two group comparison, if you have to compare two groups, if you have a mean or the percentage, then you know already there are two kind of parametric and non-parametric types are there for the test, okay. So if you have two groups, or if you have a data which is suitable for parametric analysis and non-parametric. So the parametric or non-parametric is just a parametric, you can say the structured data or the data which is very structured, or we can there is a pattern in the data, okay. Or if the data is very discrete or the different kind of data, then we consider it the non-parametric. I will discuss in detail what is the parametric and non-parametric, but for now you will just understand most of the analysis we conduct that is under the parametric, okay. So for the parametric, if you want to compare two groups, then you would select the independent two sample t-test if you want to compare two groups. If you have percentage data, you will go for the chi-square test. If you have one group, if you want to compare one group itself, then if you have mean data, then you will go for single mean or the one sample t-test. Or for parametric, you have a pair t-test. If you have one group, I'll discuss this how it happens. And the non-parametric, you select the Wilcoxon test. Now what happens if you have a more than two group? So if you have a one group, you will select this. If you have a two group, you will select this. If you have a more than two groups, then what would happen? If you have more than two groups, then you require ANOVA. So t-test ANOVA is nothing, just a method to compare the groups. If it is two, then you can apply t-test. If it is more than two, you can apply ANOVA, okay. If you have a non-parametric data, then you apply this kind of test. So these slides will tell you what kind of data we are having and what should be the test for that. So uh, let's discuss about the student t-test. So t-test is basically three different types are there. Okay, if you have a data which is normally distributed, then you can select the type based on your data, based on your data type. If you want sample t-test, then you can, if you have one sample or you want to compare within that group, you can go for this. If you have a two groups, different groups, independent two groups, this is very important, independent or the pair. The independent means if you have two different groups, then you can compare the two different groups or samples. Okay, so this is the most common one. We generally use this in most of the cases. In the paired sample t-test, what happen in paired one? Suppose you have the group of person, you are interested in the weight, how much weight is increased or in n number of day or the particular number of days. So you have recorded a weight at 0 day and then you are recording the weight at 30 days. So your sample or the person are the same at 0 day or 30 days. So that kind of data is paired because weight is paired for that particular person. So that kind of data we consider as a paired data. So for that kind of data we have to apply the paired sample t-test. So now you, I think, understood what kind of t-test we should apply based on our data. In most of the cases we apply this independent sample t-test. So this is just an example. I have used GraphPad Prism to construct this kind of graph. So I have compared this pH and NF, okay, and you can see the difference as well. And I have also applied t-test to compare independent t-test. And then this is the significance value, p-value, and I have also put this star to just get clarified. You can also make like this. How we can construct this, we'll see from the GraphPad Prism. Okay, now for that you should have a data which is in two column. So this is just x and y, and I would like to compare this. So I'll copy this data. Okay, then go to the GraphPad Prism. Okay, this is the option to select new data table. I have selected new. Wait a minute. Okay, then I will go for the column statics. If my data is categorized based on the column, then I'll select this box plot only. I'll create it here. Okay, then I paste here. Okay, so I pasted this. Now how can you analyze? Go to the analyze option. Okay, and then in analyze, go to select the t-test. So there are many options, statistical test options are there in this analyze section. Okay, you can choose any of them. So we are interested in t-test. I'll tell you detail in the later class. Okay, so we can select this t-test that is non-parametric and just okay. So now we have to select what kind of test we are applying. Okay, pair t-test, non-parametric, don't assume assumption, or just default. So we'll leave it default and press OK. When you press OK, you will get the result of this analysis. Here you can see the summary. So our data, we can say the showing significant difference at this p-value, and we are putting 3 star on that. Okay, so other things are also there, but we are interested in this. I'm just telling in a brief on it. Show you I'll discuss in later in detail. So this is our data. We have compared, we have checked our data found to be significant. It means our data is significantly different. So this is just our data. How we can beautify this? Just I'll remove this. I'll write the axis like the weight or the biomass. Suppose it is biomass of x and y group. Okay, and I'll show you how we can make it very good. Okay, we can fill this color by clicking this. Or else you can select from directly here this color option, change color scheme. Okay, you can select the scheme. Okay, there are many options are there. I'm selecting this candy soft, suppose this one. Okay, now I'm also choosing the plot area. Choose uh, plot area color. I'm selecting this one. Okay, I can also select some other options in which we can see clearly. Okay, so this is the one we have selected. Okay, now how we can interpret this? So our data is spreading from 10 to 40. This is whisker. Okay, 10 to 35, but our most of the data concentrated here between this from 28 to 30. So most of the data are scattered here for this X, and for Y our most of the data are here from 11 to this. So likewise we can consider, and the middle value, if we get a line here, then we can consider the mean or the median of that data variable. So we had applied t-test here. Okay, so values, this one or 3 star is there. So I'm copying this. This is our data type. So I am putting a line here. We can draw some lines here. Okay, I'm drawing it like this. I'm just doing it fast, so you can also verify it. Okay, now we paste our values here. This is our value. We can select this thing. We can paste it. Okay, this is our value. We can increase or decrease the size. Okay, and we can also put the star over here, like 1 2, sorry, 1 2 3 star. We can arrange it here. Now our analysis is complete. So what it is showing us, so how we can interpret the result. So we have compared biomass of these two groups. Okay, and we got the significant difference between them. Okay, and we have also uh, tested with the t-test, that is independent uh, t-test, two sample t-test, because one sample in this, one sample is this, and we have also pasted our p-value at which it is significantly difference, or we can also put the star. So this is our complete thing. We can represent this very well in paper or wherever you want to show it. Okay, I hope this is clear to you. Now next I'll tell you how we can perform ANOVA and all. So we have this data type. I'll select this. Okay, and then here are the some option for the one-way ANOVA. I'll select this. Okay, I'll just leave it default and press OK. So this is our ANOVA table, and it is showing the significant difference among the group. What ANOVA tell us? There is a significant difference among the group. It means these are W, X, Y, Z are there. Okay, so by t-test we can compare only 2, but if there are samples more than 2, then we have to go for ANOVA, and ANOVA is telling us that there is a significant difference, as you can see the star and the p-value. Okay, now this is one more important thing about the test is if you have a t-test, we can like this. Or one more thing, this is just ANOVA when we apply ANOVA, and we apply ANOVA when we have a more than two group and we want to compare them. So ANOVA will tell us only is there significant difference between the group or not. So the one most important thing after ANOVA is the post-hoc analysis. What it is actually? So ANOVA is just tell us about whether there is a significant difference or not. Okay, I'll just read it for you. This is very good thing. The post-hoc analysis refers to the statistical test performed after the initial analysis, which is ANOVA, shows a significant result. It is used to find specifically where the difference lie among the multiple group. Okay, so post-hoc means after this. It means in Latin. So these tests are not planned. They generally done after the seeing the data. So once you check their data with the ANOVA, then you go for post-hoc analysis. When we can go for post-hoc analysis? These are the example of tests like Tukey's, DMRT and all. I think you have already heard about this. So when or why we should use this post-hoc analysis? So you have a 3 or more group. If you have 3 or more group, if you are applying ANOVA, and then ANOVA will tell us there is a difference, but not where the difference is. ANOVA what will tell us? There is a difference among the group or among the different variables, but it won't tell us about the where is the exact difference, which group is showing highest significant difference, and which are falling after that variable. So if we want to compare the groups within, if we have a sample more than 2 sample, or if you want to compare the groups and we are interested which are the significant difference, which is showing the most significant difference and which is falling after that, in that case we will apply the post-hoc analysis. You want to compare every pair of groups to see which one is significantly different. So I think this is clear you. If you have a 2 sample, you will apply t-test. If you have a more than 2 sample, you apply ANOVA. If ANOVA will tell you only there is a significant difference. And if you want to further compare the groups based on which group and which pair is most significantly different, then you need post-hoc analysis like DMRT or Tukey's test, and these tests also you can use. So we'll see from this GraphPad. So we have this data, and now I'm applying the data analysis. So just select this data or go to analyze, then column statistics, one-way ANOVA. Select one-way ANOVA, okay, because it's come under one-way ANOVA. Press OK. Okay. In the ANOVA, you can select the which kind of ANOVA you want. Okay, now here the option for the post-hoc analysis, like Tukey's. Compare all pair of column. We are applying Tukey's, okay, and we are pressing OK. Now you can see the result. So it has already compared like W from X, W from Y, W from Z. So all kind of pair you can see here, and you can also see whether there is a significant difference. Yes, it is showing the summary. With this difference and how much difference is there, we can see it by star, 3 star, 2 star, 1 star. So this is just a Tukey's test, and that we apply after ANOVA. We can apply one more DMRT or the Nanette test. Go to the analyze. Select your data type. You will see your data file here. Go to the analyze and select ANOVA, and then select this Nanette all compare column West control column. If you have something control or you want to compare the all other groups from the control, then you can select this one, Nanette test. Press OK. Now you can see if this W is control, so we have compared W with X, Y and Z, and we can see the result summary here. Likewise, we can interpret our result, or we can represent that in this table. So if these pair are showing significant difference, so we can put value like that, and we can see which variable or which group is showing us more significant difference and which is following after that. So this is just about GraphPad Prism. This is just a brief. I just told you about when we should use. Okay. So this is just when we should use. The p-value from ANOVA will tell us about at least one group is different. But post-hoc analysis will show the pair of groups which are actually significantly different. So thank you. So this is just a brief about the statistical test analysis and the GraphPad Prism. In the later class, we'll discuss in detail how we can use GraphPad Prism, on where we can get this data, how we can copy it, and we will also see the advanced analysis from this, how we can also construct different kind of graph, and we can put the statistical values on that.